Tonight, the Beaumont Public Health Department is warning about an algae bloom in Texas waters.
And as Tropical Storm Beta moves closer inland to the Texas coast, expected to make landfall later tonight between San Antonio and Matagorda Bays.
The ocean floor off the coast of Texas has always been a place of mystery and slow transformation, shaped by currents, shifting sediments, and deep tectonic forces working in silence. But the sudden occurrence of wide cracks and the collapse of large portions of this seabed marked an extraordinary disruption in what is usually an invisible and imperceptible process. A stretch of ocean floor giving way so abruptly is more than just a geological event. It is a startling reminder of the hidden forces beneath the Gulf of Mexico and the delicate balance that holds together coastlines, marine life, and even the infrastructure built along the shore. The collapse did not happen gradually over centuries as one might expect, but instead appeared almost instantaneously, a violent rearrangement of terrain deep underwater that now demands explanation. Before we start, smash the like and subscribe buttons for more updates. The Gulf of Mexico, lying against Texas's shores, has long been considered a relatively stable region compared to other tectonically active zones on Earth. Unlike the Pacific Ring of Fire or the Mid-Atlantic Ridge, this gulf does not usually produce large earthquakes or volcanic activity. Yet beneath its waters lies a thick carpet of sediments piled over millions of years, pressed down by rivers like the Mississippi and Rio Grande and by the weight of time itself. These deposits, unstable in certain places, can shift dramatically if triggered by deep geological stress, changes in fluid pressure, or undersea landslides. When the collapse of Texas's ocean floor occurred, it suggested that these forces had reached a critical threshold and the seabed simply fractured under their strain. This left behind jagged fissures running across the submerged surface, cracks that stretched like scars across a previously unbroken landscape. What makes this collapse striking is the speed and extent of it. Ocean floors do not usually alter in dramatic visible ways during the human timescale. Yet reports indicated that in some areas the seabed dropped suddenly, exposing fresh geological layers and displacing marine ecosystems in an instant. The cracks that appeared were not shallow scratches, but deep cuts, some descending far enough to hint at faulting zones or cavities beneath the sediments that had given way. The sudden creation of voids beneath the seabed can cause entire sections of the ocean floor to slump downward, much like a sinkhole forming on land. But here, instead of earth and asphalt, it is thick layers of sand, clay, and limestone reshaping in a hidden underwater theater. The collapse brings into focus how fragile the Gulf's undersea geology can be. While it does not face the grinding collision of tectonic plates like California or Japan, the Gulf of Mexico sits on an ancient passive margin, where sediments from thousands of rivers have accumulated over millions of years. These layers can reach staggering thicknesses, pressing down into the crust. Over time, salt deposits buried deep below can flow like viscous rivers, pushing and distorting everything above. This process, called salt tectonics, has sculpted strange domes and ridges beneath the Gulf waters. If enough stress builds up within these layers, or if fluids trapped between sediments escape suddenly, collapse events like the one off Texas could occur. It is a reminder that the seabed is not static but alive with pressure, weight, and movement that only occasionally breaks through to reveal itself. For the ecosystems that blanket the Gulf floor, such a collapse is a catastrophic disruption. Corals, sponges, and benthic organisms that had attached themselves to the seabed suddenly found their terrain ripped apart or swallowed by cracks. Deep-dwelling fish and invertebrates were forced to scatter as the ground beneath them shifted. Even though these organisms live in an environment that constantly reshapes itself in subtle ways, a collapse of this scale would feel like an earthquake under the ocean. Sediments stirred up during the event clouded the water, reducing visibility and oxygen levels. For species that rely on stable conditions, such upheavals can determine survival or extinction in their immediate habitat. The Gulf is already under strain from human activity, and such sudden geological change magnifies those stresses in ways science will struggle to fully measure. Beyond ecological consequences, the collapse of the ocean floor near Texas hints at broader implications for human activity in the Gulf of Mexico. This region is home to an immense network of oil rigs, pipelines, and shipping routes. Subsea infrastructure built on the assumption of relative stability could be put at risk by seabed cracks or shifts. Pipelines laid across the ocean floor might be bent, fractured, or displaced if the ground beneath them changes. Oil platforms anchored to the seabed could face altered stability if the geology below them slumps or splits. Even sonar mapping and navigation could be disrupted by changes in the seafloor's contour. The Gulf is an economic artery for Texas and the United States, and when its foundation begins to alter suddenly, the stakes extend far beyond geology. One of the most intriguing aspects of this collapse lies in the energy dynamics behind it. Oceanic cracks can be created by seismic activity, but they can also emerge from the slow release of methane hydrates buried within sediments. These hydrates are ice-like compounds of methane gas and water, stable under high pressure and low temperature at the ocean floor. If disturbed, they can destabilize sediments, causing them to slump and collapse. The sudden release of gas into the water would not only weaken the structure of the seabed, but could also alter buoyancy in the water column above. In extreme scenarios, vast amounts of methane released from the seabed could even affect the atmosphere. The Texas collapse may not have released massive plumes of methane, but the possibility underscores how tightly bound energy, chemistry, and geology are beneath the ocean. The collapse also forces reflection on how little is known about the Gulf's undersea environment. Despite decades of oil exploration, fishing, and shipping, large parts of the Gulf remain poorly mapped. Sonar surveys provide general outlines, but the details of cracks, voids, and geological stress lines are still sketchy. This event demonstrates that hidden forces can suddenly transform the seabed in dramatic fashion. Researchers may now push for more extensive monitoring systems to detect early signs of instability. Pressure sensors, seismographs, and sonar scans could give glimpses into when sediments are about to fail. But the challenge remains. The Gulf floor is vast, and the events that shape it can unfold in silence until they erupt into a collapse. The very notion of an ocean floor collapsing is deeply unsettling because it subverts the assumption of stability. Land collapses are visible and dramatic, like sinkholes swallowing cars or landslides tearing through mountainsides. The ocean floor, by contrast, hides its fragility beneath hundreds of feet of water. When it suddenly gives way, the event feels almost invisible, except to the instruments or divers who happen to be watching. Yet its consequences ripple outward, not only reshaping the seabed, but affecting life, industry, and human understanding of the Gulf. The Texas collapse embodies the power of processes that remain largely unseen, waiting beneath the calm surface of the sea. Such an event inevitably invites speculation about its scale. How wide were the cracks? How deep did the seabed sink? Were these local fissures stretching a few hundred feet, or did they extend for miles across the Gulf floor? The precise answers may take years of mapping and study to uncover, but the very appearance of cracks where none existed before is enough to confirm that forces beneath the Gulf are far from dormant. Like a scar forming across a landscape, these cracks remind us that the Earth's crust is not a finished canvas, but an ongoing work of shifting and breaking. For coastal communities in Texas, this collapse also underscores their connection to a geological foundation they cannot see but depend on daily. The Gulf's floor shapes tides, currents, and storms that batter the shoreline. It supports fisheries that provide livelihoods, and it anchors the rigs that fuel the economy. If the seabed is unstable in ways not fully understood, then the risk extends indirectly to those living along the shore. It may not be a visible threat like a hurricane, but it is a silent one, unfolding miles offshore where the water hides its scale and power. At the same time, the collapse emphasizes how interconnected Earth's systems are. A sudden shift in geology can cascade into changes in ecology, chemistry, and human industry. Cracks on the seabed may alter how currents flow, creating eddies or shifting nutrient patterns. Sediment plumes can choke delicate coral systems. Disrupted pipelines could spill oil or gas, further affecting marine life. Each of these outcomes begins with a simple but immense fact. The ground beneath the ocean, once assumed stable, has given way. The Gulf of Mexico is a dynamic arena, and Texas now finds itself at the edge of an unfolding geological story that will continue to reveal itself as the cracks are studied. Even as scientists investigate the cause, the imagery of a collapsing seabed carries weight. It evokes the idea of hidden fragility beneath the surface of everyday life. People may stand on Texas's beaches watching calm waves roll in, unaware that just beyond the horizon, the very floor of the ocean has broken apart. This disconnect between what is visible and what is true deep below is what makes such events both unsettling and fascinating. The collapse of the Texas ocean floor is more than a geological occurrence. It is a dramatic punctuation mark in the slow sentence of Earth's shifting crust. The cracks, now etched across the seabed, will remain as enduring evidence of that moment when stability failed. They will be mapped, measured, and revisited by expeditions seeking to understand their origins. They will remind us that even in places thought to be relatively quiet, the Earth holds surprises that can unfold without warning. In the silence of the Gulf, the collapse echoes as a lesson in humility before the forces that shape our world. Texas, with its long coastline and deep ties to the sea, has witnessed a transformation far beneath its waters, one that adds a new chapter to the story of its ocean and the hidden ground on which it rests. The collapse of Texas's ocean floor has forced an entirely new focus on the hidden mechanics of the Gulf. While the initial cracks and shifts have already revealed a startling change in the seafloor, the broader implications stretch far beyond geology. This kind of disruption reshapes our perspective on how interconnected every layer of Earth is, from the core to the surface waters and even into the atmosphere above. A collapse of this magnitude is not merely an isolated event at the bottom of the sea, it is a statement from the planet itself, showing how much remains hidden beneath the calm exterior of the ocean. One of the most striking elements of this collapse is the scale at which natural forces must have operated to tear through such a dense and layered seabed. Sediments at the bottom of the Gulf are not loose sand that shifts with a current. They are compacted strata, cemented together by pressure over thousands and even millions of years. To cause sudden cracks and collapses within that framework implies either an overwhelming release of built-up stress or the failure of massive supporting structures within the seabed. Salt domes, long known to deform under weight, may have flowed away from beneath, leaving voids that ultimately could not hold. Alternatively, fluids trapped between layers, superheated brines or methane hydrates, may have destabilized the equilibrium, turning solid ground into shifting terrain. The forces involved are almost inconceivable on a human scale, yet they are real and active beneath the waters just off Texas's shores. The Gulf of Mexico is unique in that its geological history combines remnants of ancient seas with vast influxes of river-borne sediments. This makes it a natural repository for instability. Unlike mountainous regions where tectonic plates grind visibly, the Gulf hides its dynamism under a flat and seemingly featureless surface. Beneath, however, every layer tells a story of flooding, retreating seas, and rivers that once carried entire continents' worth of soil into the basin. When those ancient layers break apart, they do so with the combined weight of their history pressing down. The cracks in the Texas seabed are not just fissures, they are time capsules split open, exposing deposits that may not have seen light or water exchange in millions of years. For scientists, this sudden access to new layers provides an unplanned laboratory, offering direct samples of past climates, chemical compositions, and ancient microbial life. The collapse also forces attention toward the Gulf's vulnerability in ways rarely considered. Hurricanes and storms dominate headlines because they strike visibly at coasts and cities. Yet the ground beneath the Gulf, though hidden, represents a slower but potentially more transformative risk. If one portion of seabed can fail so abruptly, others may follow under the right conditions. Texas's long shoreline, with its ports, refineries, and growing coastal populations, depends upon a stable ocean foundation. A collapse alters seafloor topography, which in turn can influence wave patterns and storm surges. Even subtle changes in depth can redirect currents, amplifying the force of water during hurricanes or reshaping the way sediments accumulate near shore. For a region so tied to its coast, even these indirect changes could matter as much as the collapse itself. For the oil and gas industry, the seabed collapse is a wake-up call of another kind. The Gulf of Mexico remains one of the world's most productive offshore drilling zones. Rigs and pipelines extend across wide swaths of seabed, built under the assumption that the ground beneath them is static. Engineers design for storms and corrosion, but rarely for the possibility that the floor beneath the equipment might split or sink. If cracks open beneath a pipeline, stresses could cause ruptures with devastating effects. If a rig's anchors are set in ground that begins to slump, stability may falter. The collapse demonstrates that the Gulf floor is not immune to sudden rearrangements, meaning companies may have to rethink how they survey and prepare sites for decades of use. Greater investment in seafloor monitoring may now become a necessity, not a luxury. The cultural implications of such an event are just as profound. Texans are deeply tied to their Gulf, whether through fishing, shipping, or recreation. The idea that the very ground beneath the ocean could collapse may seem abstract, but it challenges assumptions about safety and permanence. For generations, the Gulf has been viewed as a relatively tame sea compared to the vast Pacific or Atlantic storms. But this collapse reminds coastal communities that they live alongside a restless Earth. Just as inland regions confront the unpredictability of tornadoes or mountain towns accept the risk of avalanches, coastal Texas may need to recognize the instability of the seabed as part of its environmental reality. On a scientific level, this collapse also deepens the urgency of ocean floor exploration. Modern technology has mapped more of the surface of Mars than it has the bottom of Earth's oceans. The Gulf of Mexico, despite its economic and ecological importance, still contains vast uncharted regions. A collapse of this scale underscores the gaps in knowledge. Scientists will now press to expand sonar mapping, deploy remotely operated vehicles, and perhaps even position permanent instruments across vulnerable zones. Learning the signs of a pending collapse could be as vital as predicting a hurricane. But unlike storms, which follow atmospheric patterns, seabed failures may not present obvious warnings. It will take careful study of seismic signals, pressure changes, and chemical leaks to build a predictive framework. The collapse also has implications for marine archaeology. The Gulf has long hidden shipwrecks, some dating back to colonial times. A sudden seabed failure could bury or expose wrecks in ways that transform how history is preserved under the sea. Artifacts long entombed may suddenly be visible, while others carefully cataloged may be swallowed by new cracks. The Gulf's role as a historical repository is no less important than its geological or ecological functions, and any dramatic change in its floor reshapes that legacy. From an ecological standpoint, the effects of cracks and slumping extend beyond immediate destruction. As sediments shift, they release nutrients and minerals into the water column, creating temporary blooms of microbial life. These changes ripple up the food chain, altering the balance of species that rely on stable nutrient flows. Some organisms thrive in these new conditions, while others decline sharply. Over years, entirely new ecosystems can form around cracks, especially if methane or other gases seep continuously. These areas may become hotspots of unique microbial activity, potentially offering new insights into life's adaptability under extreme conditions. Thus, even in destruction, the seabed collapse may plant the seeds of novel environments. Another dimension to consider is the psychological impact of an event so hidden, yet so vast. Human beings tend to perceive threats in terms of visibility, storms, floods, wildfires. The collapse of an ocean floor, invisible to the naked eye, challenges perception itself. Knowing that the ground beneath the Gulf fractured suddenly creates a sense of unease, because it undermines trust in what is assumed to be permanent. For people whose lives are tied to the sea, from fishermen to energy workers, that uncertainty can carry as much weight as the event itself. It is not only about what happened, but also about what could happen next, and whether it could unfold without warning beneath waters relied upon daily. The collapse also links Texas to a global narrative. Ocean floor failures have been recorded in various parts of the world, often tied to submarine landslides. These landslides can trigger tsunamis if large enough, reshaping coastlines far from their origin. While the Texas collapse may not have created a surface wave, it places the Gulf within the category of regions where such risks exist. This shifts the Gulf's geological profile closer to that of more volatile zones, suggesting that the global ocean is far more connected in its vulnerabilities than once believed. Texas now shares in that vulnerability, adding a new layer to its relationship with the sea. Looking deeper, the collapse invites speculation about the role of climate-driven changes in oceanic stability. Warming seas expand and alter circulation patterns, affecting pressures on the seabed. Increased storm activity stirs sediments more violently, weakening their cohesion. Melting ice in distant regions adds to sea level rise, which in turn changes how water weighs upon continental shelves like that of the Gulf. While it would be simplistic to draw a direct line from climate change to this collapse, the interplay of pressures and stresses cannot be ignored. It is entirely possible that human-driven alterations of Earth systems have nudged fragile undersea zones closer to failure. For future generations, the collapse of Texas's seabed may become a pivotal case study. It illustrates the need to understand Earth as a whole, where geology, climate, and human activity intertwine. Universities, research institutions, and governmental agencies may point to this moment as the reason for expanded funding into ocean monitoring. High-resolution seafloor maps, once considered luxuries, could become essential tools of planning. Engineering courses may adapt to include seabed instability as a standard factor in offshore design. Even in the cultural imagination, the event may take root as a reminder that the ground beneath the ocean is not as eternal as it appears. The cracks themselves will become part of this legacy. As expeditions return to study them, they may discover entirely new biological communities, chemical exchanges, or geological processes. The scars left by the collapse will remain for centuries, long after the event itself is forgotten in headlines. They will stand as evidence of the moment when Texas's Gulf floor betrayed its hidden weakness and as a permanent laboratory for learning. Every new dive into those cracks will echo the suddenness with which they appeared, and the vast implications they carry for science, society, and the environment. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Texas's ocean floor collapse and sudden cracks forming? We want to hear from you. Thank you for watching and see you next time.